Have you ever gotten an answer from an AI and thought, that feels a little too perfect, a little too neat and tidy for the real world? Well, you're not imagining it. Turns out there's a really fascinating reason our chatbots seem to have this secret optimistic streak. Let's dive in.
Yeah, it's an experience a lot of us have had. You ask a large language model a pretty straightforward question about the world, and the answer you get back sounds right, but it doesn't quite line up with the messy reality we all know. It almost feels like the AI is describing the world as it should be, not the complicated world as it actually is. Okay, so check out this perfect example from the research. You ask an AI how many sugary drinks a typical person has in a week. It might say something like 4.5. Sounds plausible, right? But the real statistical average is closer to 9, almost double that. So the AI's answer isn't the average. It's somewhere between messy reality and a healthier ideal. So what's going on here? To solve this little mystery, the researchers did something really cool. They didn't just dig into code and algorithms. Nope. They turned to cognitive science, and they found a powerful parallel in the way our own minds work. Turns out, to really understand our AI, we kind of have to understand ourselves first. And this brings us to a concept called System 1 thinking. Think of it like your brain's autopilot. It's the part that makes quick judgments and uses mental shortcuts to get through the day without overthinking everything. It's fast, it's intuitive, and here's the kicker. Researchers believe that large language models are basically running on a very similar System 1-like operating system. So this System 1 thinking, whether it's happening in our own heads or inside an AI, it involves this constant balancing act. You can picture it like a tug of war between two different kinds of information, the world as it is and the world as we think it should be. On one side of that tug of war, you've got what's called the descriptive norm. This is super simple. It's just the facts, the statistical reality. It's the way things actually are, like the fact that on average, people have about 8.6 sugary drinks a week. It's just a description of reality, plain and simple. But on the other side of the rope, pulling in the opposite direction, is the prescriptive norm. This isn't about what is, it's all about what should be, our sense of the ideal. We all know that ideally, a person should have way fewer sugary drinks, maybe even zero. That's not a statistic, it's a value judgment, a goal. And boom, that's the core idea right there. The AI starts with this statistical average. That's our messy reality. But it's also aware of this unspoken ideal, the way things should be. So its final answer isn't one or the other. It's a blend, a compromise that gets pulled away from the real average and tugged closer to that perfect ideal. Okay, that's a neat theory, but how on earth do you actually prove it? I mean, you can't just ask the AI what it's thinking, right? So this is where the researchers got seriously clever with an experiment to isolate this very effect. They invented a completely fake hobby called glubbing. By using a new concept, they could be sure the AI had no preconceived notions. They fed the model 100 data points showing people spent an average of 45 hours glubbing. Then, and this is the genius part, they added that ideal component. They told the AI that more hours of glubbing got an A+, and in another test that fewer hours got an A+. Then they just asked the AI to pick a typical number of glubbing hours. And wow, the results were crystal clear. Look here on the left, when more hours were the ideal, the AI's answers were consistently higher than the actual average. And on the right, when fewer hours were ideal, its answers got pulled lower. This is the smoking gun. The only thing that changed was the ideal, and the AI's answer followed it perfectly. So we know the theory works in a controlled lab with a fake hobby. But does this prescriptive pull, as they call it, happen in the real world with concepts the AI actually knows about? The answer is a huge yes. For waiting on the phone, the ideal is fewer minutes, so the AI's answer gets pulled down from the average. For exercise, the ideal is more hours, so its answer gets pulled up. For sugary drinks, the ideal is 0, and its sample is pulled way, way down. You see it? The pattern is undeniable. And listen, this wasn't just a few cherry-picked examples. The researchers confirmed this pattern across an incredible 500 different real-world concepts, covering everything from health to economics. The effect was real and statistically significant every single time. What's really fascinating is that this isn't just a quirk of one specific model. They tested 15 different AIs, and the effect was there in all of them. And check out this trend here with the llama models. As the model gets bigger and more capable, that pull towards the ideal actually gets stronger. This seems to be a fundamental feature of how these things work. So at this point, you might be thinking, okay, so the AI is a bit of an optimist. What's the big deal? And, in many cases, it might be totally harmless, maybe even helpful. But what happens when we start relying on this AI for high-stakes decisions? To find out, the researchers ran another test. This time, they put the AI in the role of a doctor making decisions about patient recovery times. And the stakes really don't get much higher than that. And their findings were pretty alarming. The AI's internal ideal was, naturally, a faster recovery. That's what we all want. But this prescriptive pull biased its judgment. It consistently suggested that patients could be discharged sooner than the statistical average for their symptoms would recommend. And that could create a very real risk to patient safety. And this wasn't just a fluke. The results were statistically significant, with a p-value of 0.003. In simple terms, that means there's an incredibly tiny chance this happened by accident. This bias toward dangerously optimistic recovery times is a systematic error baked right into the model's decision-making process. And this brings us to a really important final point. Because while the AI's thinking process seems to mirror our own in some ways, there's a crucial difference in how it actually conceives of an ideal. So if we look back at the glubbing experiment, we can see the results side by side, humans on the left, LLMs on the right. The pattern is strikingly similar. We're both pulled by the ideal. But just notice how that pull can be so much more extreme for the AI. And this slide shows exactly why. When you ask a person what the ideal number of sugary drinks is, they'll say something reasonable, like 2 or 3 a week. But when you ask an LLM, it often defaults to a kind of moral absolutism. The ideal is 0. Humans have nuanced ideals. AIs can be much more black and white. So this leaves us with a critical question to think about. We're building these powerful tools that have an internal compass, a sense of what's ideal. But that ideal might be more rigid, more absolute, and in some cases, less wise than our own. And as we rely on them more and more, we have to ask, how do we make sure their compass is pointing in a direction that's truly helpful and not just perfectly, dangerously ideal?